Hi there. In today's topic we will be discussing about electric air travel, how electric air travel goes mainstream. Speaking of sustainability, it looks like flying Teslas are finally here. And they have the potential to make a big impact on at least 3 large industries. The aircraft manufacturing industry, with over $200 billion in annual revenue between the top 3 manufacturers alone, Boeing, Airbus and Lockheed. Commercial airlines, with $838 billion in annual revenue, pre-COVID. And the ride-hailing and taxi industry, which was valued at $219.68 billion in 2022. An electric aircraft from Airbus. Electric vehicles are cheaper to run, less expensive to maintain, and better for the environment than vehicles powered by conventional fossil fuels. That's just as true for aircraft as it is for cars. When it comes to electric aircraft, there are 2 main types, fixed-wing airplanes and eVTOLs. Fixed-wing electric airplanes are just what they sound like. There aren't any 747-sized electric airliners yet, but smaller commuter planes are in production. Eviation is leading the charge. This startup produces a 620-mile range, 9-seat commuter plane called the Alice. According to the company, flying the Alice is dramatically cheaper than a regular internal combustion-powered airplane. For a 100-mile flight, conventional fuel for a similar-sized Cessna would cost about $400. In Eviation's electric Alice, it would only be about $10. Eviation recently merged with Claremont Aerospace after a $108.5 million valuation. Eviation's electric commuter plane, the Alice. At the same time, Aerotech and Magnix are teaming up to retrofit existing airplanes with electric motors, with similar improvements to efficiency. There are also electric hybrid airplanes in development. For example, the Project 804 by United Technologies, as well as the Aero by Zunum, a startup backed by Boeing and JetBlue, and the eFan X by Airbus and Rolls-Royce. This project was shut down in April 2021, but only after achieving its 3 main initial research goals, according to Airbus. That covers fixed-wing electrics. The other major kind of electric aircraft is the eVTOL. eVTOL stands for Electric Vertical Takeoff and Landing. Non-electric VTOL examples include anything from helicopters to drones and Harrier jump jets. eVTOLs tend to be smaller than their non-electric cousins, and designed for shorter flights across cities. Some look like passenger-carrying quadcopter drones, while others have a fixed-wing component like regular airplanes. Search interest in eVTOLs has been exploding lately as startups and major aircraft manufacturers demonstrate new eVTOL models. Searches for eVTOL have increased by 1,550% over 5 years. In July 2020, Airbus conducted the first public flight of its autonomous 4-seat City Airbus multicopter eVTOL. The City Airbus has a projected range of about 60 miles, or 15 minutes. The City Airbus multicopter. Airbus also has Vahana, in development by its Silicon Valley innovation arm, Acubed. For its part, Boeing's Aurora Flight Sciences has been developing solutions for an air taxi service in partnership with Uber, including an autonomous electric passenger air vehicle. Separately, Boeing is also reportedly partnering with Porsche to develop another eVTOL. And Tokyo-based flying car manufacturer SkyDrive raised a Series B of 3.9 billion yen, about $37 million, and conducted its first public manned demonstration of the SkyDrive ST-03. The ST-03 is the world's smallest eVTOL, requiring only as much space on the ground as 2 parked cars. That small footprint is one of the main advantages eVTOLs have over traditional fossil fuel-powered VTOLs like helicopters. eVTOLs like the ones mentioned above use multiple smaller electric motors with rotors spread out across the aircraft, whereas a typical helicopter uses one main internal combustion engine with 2 huge rotors stacked above, plus a smaller one in the tail. eVTOL's multi-motor design is called a Distributed Electric Propulsion (DEP) system. DEP systems have numerous advantages. They make piloting easier, reduce the footprint required for takeoff and landing, and increase safety through redundancy. If one motor fails, there may be 7 more still running. They also reduce noise emissions, as the rotors don't have to spin as fast. Noise and vibrations within the cabin are lower as well. Thanks to these advantages, dozens of eVTOL manufacturers are currently vying to capture a share of the nascent urban air mobility market, eVTOLs used to fly over traffic. Germany, Holland, Belgium, France, Mexico, and Brazil have all been experimenting with urban air mobility initiatives. But with all those benefits, why hasn't electric air travel caught on before? 2 words: energy density. In other words, the amount of stored energy in 1 pound of fuel, whether gas, diesel, kerosene or batteries. Currently, conventional fossil fuels have more energy density than batteries. That's why electric cars are generally heavier than their gas-powered counterparts. They have to be, in order to store enough power. For aircraft, this added weight poses an obvious problem. But it's a problem we're getting closer to solving. Tesla CEO Elon Musk has said that an energy density of 400 watt-hours/kg, watt-hours per kilogram, is the crossover point for lithium-ion batteries to beat kerosene jet fuel. Once battery technology reaches that level, the sky's the limit for electric aircraft. Today, the energy density of industry-leading Tesla batteries is currently about 260 watt-hours/kg, up from 124 watt-hours/kg in 2007. So when might we get to 400 watt-hours/kg? Very soon, according to Musk. Though he has also said that Tesla has no near-term plans to make electric aircraft.